Okay, so we'll start with the Buildly configuration, setup, and directory structure, at least the directory structure that I like to use. So this is my structure for Transparent Path. I usually start by creating a projects folder and then build up by cloning the required repositories. I have the CLI tool in my main Buildly directory, and then I have a project directory. So this is for Transparent Path. I have the core clone in here, the fork from that particular project. In this case, Transparent Path again, and then a couple of other Intel sensor data that are related but not directly services. I usually then create a service directory and an ops directory. The ops directory is again a clone of the original Buildly ops directory with the Helm charts and the Terraform configuration. So if we go into services, we will see a list of the services that I've created. There's an admin, there's a React template. Those are for, again, the front-end components, a front-end admin and a front-end React template. A custodian service, which is a back-end Django service. A sensor service, again, Django, and a shipment service. Those are all set up as logic modules inside the Buildly core, and I'll show you how to do that when we get to that part. So if I go now back up a directory, we can go and look at the ops directory. And this has our Helm charts and our Terraform configuration. If I go into the Helm charts directory, you will see I have ingress charts from Nginx. That's what we were using there. And instead, we now use the application load balancer for AWS services. But you can see we've got a chart for the Buildly core, for the UI, for each service. And this is just a basic directory for all of the Helm charts, but you can change it a little bit. But what you want to be able to do is have a Helm charts directory that you keep all of your services and core in, so that when you deploy later on, you'll be able to use that directly. So usually we use the Helm command directly here instead of via a commit to the Terraform function in the Terraform cloud, but you can do it either way. But this is just my suggestion and how I use it. So if we go back up to the ops directory again, you'll see the Terraform directory, and there we'll have options for the different services we support: AWS, DigitalOcean, and Google Cloud. Usually, for most of the projects right now, we're doing AWS, and then you'll see all of the Terraform scripts, the application load balancer, the EKS, that's essentially for setting up a Kubernetes instance inside of Amazon, the Helm charts, which can then be triggered through this service, so you need to then have those directories mapped. If you look at the Helm file, you'll see that it maps back to those charts and then the value file that's in there as well. And that's so that it can then trigger those from the cloud directory as well. So that the whole ops directory gets checked in with the Helm charts and the Terraform charts and gets run in the Terraform cloud. Okay, so we will quit that. And again, we'll go back up to our main directory and our Helm charts. We'll start with the kubectl config. So this will tell you, you can get a help by just going through here, and this will tell you all of the options you have for your context. Essentially, what we want to be able to do is have multiple clusters and multiple contexts in our command line, so that we can then use them and bounce back and forth between projects, and then set a cluster or set a context to then use it. So if we list out our current contexts, you'll be able to then see under config, sorry. All of the ones that are configured. So I have a Minikube for local configuration. I have the Buildly 9404, which is actually our Media Mash project, and then 81KC, which is transparent path. I have both of those configured here as well. And I can then set my context. I can also show what my current context is. You can see that the asterisk here next to the 81KC, which is switched there. And now I can run the same command again, and I will see the context for Media Mash properly. So now I can switch back and forth by, I'll again do my get contexts here, and I can see that I've switched over to that namespace. I can then switch back to transparent path by running the use context, not set context. And in US West 2, which is where transparent path is, I've now switched, and I can run get pods, and I can see now these are all the services running on the server itself: custodian service, sensor service, and shipment service. So now we'll go over to the services themselves. So I'll start by going to AWS and signing into the console. And now I can see at my top level that I am in US West 2 Oregon, and I can go and look at the EC2 instance there, or instances that are running there, and I can see all of the load balancers that are running for each one. And the load balancers are going to be important to be able to access because that tells you the URLs that have been generated for those. So if I look at Buildly Core, for example, I can see the DNS name, the A record that gets added, and then I can also see the ARN for that load balancer, and the listeners that are configured for it, port 80 and port 443. This then tells me where these rules are and where those are getting forwarded. But I know that because this is in DNS, if I then go look at Route 53, I can then see the configuration there that's set up for those URLs. So I go to my one hosted zone, then I go to the Buildly domain. And this is where all of our dev servers are going to be located. And you'll see down here we have the mmdev entries. That's for the Media Mash, and then here are the tpdev. So tpdev-api is going to be our core Buildly Core API, and then these are set up, configured to be added externally. They can also be added internally to the internal DNS just through IP addresses, but these are configured externally. So I can see first from the tpdev on the API side, I can see here's the Buildly load balancer added in as the new directory. So that allows it then to be exposed as well as part of the cluster. And then I can also go and look at the sensor service, for example, and see here is the sensor service and that URL. And if I go back here to our EC2 load balancer, you can see the entry again for the core, and then here is the sensor service, and that is the DNS name for that as well. So those are now accessible through those direct instances. And then if I go to tpdev-api, Buildly, you'll see the default homepage for that. So you can actually then go directly to the documentation, which is then our links to the read the docs, the API spec for Swagger, and the UI and administrator information. But then we have your API, which takes you directly to the Swagger for your core, and then the documentation. If I go to the documentation now, I will see all of the information for that core, build the core users, the data mesh, and the logic modules. And then if I filter, I can look for sensor, and I can see the sensor service is now part of that same API endpoint. They're on a different URL. It's being proxied through this process, but I can see then sensors is the service itself, and then sensor is the set of endpoints that I can then get for the sensor service itself. I can see that data here, and it can all be accessed through this same process, as well as accessed through the core functionality and data mesh. So I can then create join records between multiple services there. So that's the basic configuration. If I then go to see how that's added, I can go into my core admin, which I'm already logged into, and I can then see the logic modules for the data mesh and the logic module configuration for the core. There's one set up for each custodian service, sensor service, and shipment service. If I click on sensor service, I can see here's the URL that's configured through Route 53. I can also set that up through access via an exposed Minikube close by just exposing the load balancer there directly in a local instance, or an IP address if it's inside of the VPC, or a generated URL if it's AWS. And I can see the API spec has been downloaded here. And every time I make a change to this spec, I need to reload it here. And there's an endpoint for that to do it programmatically, but there's also, you can just delete this entire thing, reload it, and then go back to the API endpoints here in the docs. So if I go here and I delete sensor service data and save, the sensor service will still be there. And all I have to do is refresh. It will then go out and load that Swagger document, refresh the data, and then when I come back here to the sensor service, it's loaded again with the new sets. So that's the basic configuration. We can go a little more into Minikube and another screencast that'll help you get through that. But this is how to get started if you've already got the dev server up and running, as we do now for Media Mash, and hopefully we will for the next projects. All right, thanks.